Hi, Emily. We will be starting in a few minutes. I'll be right back. Good morning, everyone. We are going to get started in 2 seconds. Let's see if anybody else shows up. Oops. Okay, it's 8:01. Let's get started so you guys can get on with your day. Are there any questions before we get started back into chapter 9? Okay, I'm going to grab my PowerPoint that I was using the other day. Just wanted to go back and that's not what I wanted. Okay, let me share and then we can figure out where we're going to be. Okay, so the other day we were talking about internal rate of return. Let me go back one. And internal rate of return is the point where your net present value is 0. So in the beginning of the chapter, we were using a rate of return and saying, okay, if we have a required rate of return of 10%, and we know we're going to have to pay this much money up front, and then our cash flows each year at the end of the year will be this amount, and they were always positive. We're going to deal with if they're negative today. What would be the net present value? So would it be a positive dollar amount? Would it be a negative dollar amount? So if our cash flows, net present value, are more than our cash, so our cash inflows, net present value, brought back to present value, are more than our cash outflow, it was positive, and we would probably take on the project. Where if it was opposite, it would be considered negative. Well, what internal rate of return is saying, well, determine the point that it's not positive or negative. What interest rate would we really be earning on that project where the present value of those cash flows in the future and the outflow today is 0. So it's just a different approach. And then that is compared to what you would like to see happen on the project. So I think I'm going to grab my book here. So if you have your book, I know we're going to be referring to it today for pictures and things like that. If you go to present value, I want to do a quick example. Oh, you know what? I'm not going to use the book. Let me make up my own example. Let me share some Excel. I'm not going to do the calculation in Excel, just give you the data. And I'm just making this up. So let me share my screen so you can see this. Stop sharing that and come over to Excel. Okay. So let's say in year 0, you have a project that you're thinking about taking on, and you have to expend $100,000 for the equipment related to it. And at year 1, you're going to use this equipment, and the cash flow, the positive cash flow that will come in at the end of year 1 is $30,000. The end of year 2 is $60,000. And at the end of year 3, $150,000. Okay, so we'll just do 3 years. This project's it's going to last 3 years, the cash flow from it. So that is what we're looking at. Should we take this project on is the question. Well, when we calculated net present value, we said, well, what kind of rate of return would we like to have on this project? And then we determined, did it end up being a positive or negative net present value? With this, we're going to calculate the internal rate of return. Remember our calculator, we can do this. Mine is in my apps and finance. And then my internal rate of return calculation is right after net present value. So again, you need to refer back to your calculator instructions on how to calculate internal rate of return. A million YouTube videos out there. But I'm selecting mine. And then for my calculator, the first thing I have to do is put in right after the IRR parenthesis, the cash outflow. So I'm going to put that in as a negative 100,000, comma, and then I start my bracket, and then I show the inflows, 30,000, comma, 60,000, comma, 150,000. Close my parenthesis, or I'm sorry, close my bracket, and then close my parenthesis. And I'm getting an internal rate of return, wow, of 44%. So 44 I'm getting. So that's telling me at the point this project's net present value is 0, you're getting a 44% return. So if your required rate of return is 10% or 15%, you're definitely taking on this project because your internal rate of return is much higher, the amount of return you're actually making on this project. Now I'll probably mess it up a little, but let's see if I can do it. Practice before class. So, but we do have an internal rate of return function here. And in this, it just wants to know as an array or a reference to cells that contain numbers for which you want to calculate internal rate of return. So I'm going to say C4 to C7. Those are the cells where my numbers are. See if I do it. And I hit OK, and it calculated my internal rate of return on those numbers. So you can very easily use Excel to do this computation. Are there any questions on what it's calculating? Okay, so remember, these are tools we use to decide if we're taking on projects or not. So now we're going to move on. And internal rate of return is a very frequently used tool, as well as net present value. Now we're going to look at some issues with using internal rate of return. So I'm back to my slideshow. And we did that. So we looked at this the other day. Internal rate of return does look and answer all of the major questions when we are trying to make a decision about a project. Does it account for time value of money? Absolutely. Does it take into account the risks of cash flows? Yes, because we're calculating a discount rate. Does it provide an indication about the increase in value? Absolutely. Okay, so yes, we should consider internal rate of return as one of our decision criteria tools. Okay, then we talked a little bit about the advantages there, and there was the spreadsheet. So just to review, before we get into the new stuff now today, the net present value for the project we looked at the other day using this presentation said accept it, because it was a positive, I think 12,000 something. Payback period though said no, don't. So did discount payback period and that average accounting return. Now remember, there's inherent problems with using any of those three that would have rejected this project. And we talked about those various problems. Especially none of them, except for maybe discounted payback period, will look at time value of money in any of the calculations. But the internal rate of return said, yeah, accept it. So we probably know what we should be using out there now when we're trying to make a decision. Net present value, internal rate of return are your key ones. The other ones are okay for minor decisions, very short term. Quick decisions. But with Excel now, they're all quick. Now, net present value and internal rate of return will give us the same answer when we're trying to make a decision, except for two areas. And you need to be aware of this, because if you're trying to decide to take on a project and you're using internal rate of return or net present value, you're going to have some things that don't work out. And the first one is called non-conventional cash flows. So far, the examples we've looked at, all the cash flows in the future are positive. But what if a cash flow in a future year is negative? Now we're in non-conventional cash flows. Positive, negative, positive, negative. It's harder to use. Internal rate of return and net present value. You can't just calculate it and look at the answer. You have to dig deeper into it. We're going to look at that. Another is mutually exclusive projects. And that's where you can only do one project or the other. And the example they give you in the book is a great example. It's you're going to go to law school. You could either go to Harvard or Stanford. So you can only do one or the other. Okay. When initial investments are substantially different, there's issues, as well as the timing of cash flows are substantially different. These need to be not only calculated, but really looked at. So we're going to show you how we do that today. Now, when you have an internal rate of return calculation and there's non-conventional cash flows, we're going to go through the example. The PowerPoint doesn't do it. We're going to do it in Excel and show you this. When the cash flows change signs more than once, there's going to be more than one internal rate of return. So when you solve for your internal rate of return, you may only get one of them. It's not going to tell you all the possible internal rates of return. You actually have to try to figure them out. So we're going to take a few minutes here and we're going to use our book, and make sure you understand that example that they run through in the book. And this is on page 289. So I'm going to go over to Excel because, oh, you know what? Actually, I forgot about this one. Let's use the example in the PowerPoint. Okay, back up, right? We could also take a look at the one in the book if we have time, but this one gives another perspective. So jot these numbers down. Your initial investment is $90,000. Year one, you're going to have a positive 132,000. Year two, a positive 100,000. And year three, a negative 150,000. Okay. Now, if you just put that information into your calculator and solve for the internal rate of return, which I'm going to do that. I'm going to go and do my apps, finance, internal rate of return, or you could do this in Excel. I'll put my negative 90,000, comma, don't forget the comma. I always do, and I'm always getting stuff wrong. I'm like, why did I do wrong? Oh, I forgot the comma. Open up the bracket and then put your positive first year cash flow, comma, second year's cash flow is positive, comma, and then don't forget negative 150,000. For that third year, you want to close your bracket and then close your parenthesis. And you get 10.11%. Okay. And it says here, oh, your required rate of return is 15%. Now, if you just went off of that, you would have said, oh, we can't take on this project because we require 15 and we're only getting 10.11. Or are you? So what you should do at this point is calculate your present value under various rates of return. Create a table of them. So what we're going to do is just that. And you could see there that this goes from across the bottom. These are your interest rates, various interest rates, 0, 0.05, 0.1, 0.15, etc. The vertical axis is the net present value that results from each of these discount rates. So we're actually going to calculate net present value for each of these rates. So I'm going to go back into my calculator, finance. Now I'm going to do a net present value calculation. Now, if my discount rate is 0, so I'm going to use a 0% interest rate, I put a comma, I put my negative 90,000, comma, create my bracket and put my cash flows. So my first year was 132,000. It's much easier in Excel doing this. My second year is 100,000. And my third year will be a negative 150,000. Close my bracket, close my parenthesis. My net present value is negative $8,000. And that's what we could see here. Now let's do this calculation. The only thing we're going to change is the discount rate or the interest rate. We'll change it from 0 to 5%. So I'm going to go back in. I know you can copy this, but I haven't looked that one up yet. And I'm going to put my information in again, but this time I'm going to put 5%. So 5, comma, do my 90,000, comma, my bracket, 132, 100 and negative 150. Close the bracket, close the parenthesis, and I get 3,159. So you can see the plot there, but it's negative. Now at 0.1 or around there, 10%, it's really 10.11, that's where my net present value is 0. But now look, if it goes up to 15%, it's positive. So let's just go out to 25%. Let's use that now. So you can do each of these calculations in your calculator or utilizing Excel. But when your sign changes, you should go through this exercise and plot this and find out where is my range of internal rates of return. So take a look at 25%. So now go in, do my MPV. 25 will be my interest rate, and then put the rest of the information in. And if you know how to copy that, excellent. I'm getting there. Oh, I screwed up. 132 is our first number. Comma, 100, comma, negative 150. Bracket. So at that rate, at 25%, your net present value is 2,800. Now go to 45%. So you're calculating all these and graphing them. All right, so we have 45%. Putting my information in. I'm getting negative 605. So somewhere around here where my line crosses my axis, my horizontal axis here, I have another internal rate of return. So it's somewhere between 40 and 45%. So it looks to be about 42%. So test it. And you have to do some playing around with that to determine it. So I'm going to put 42, comma. I know it's 42.66, but I'm just going to pretend I don't know that. And then my numbers. And that's where it's around 42%. It's still positive 163, but it's nearing 0. So there's really 2 points, 42.66 and 10.11, where the net present value is 0. So that means there's 2 separate internal rates of return. Now, remember what I said. Our decision-making criteria was, well, if the internal rate of return is not 15%, we're not going to take this. Well, that's not true. The internal rate of return, where net present value will actually be positive, is over this entire range of rates. So if our required rate of return is between 10 and 40, almost 43%, we should accept this project. So you can see just taking that initial, 10.11, no good. When you have unconventional cash flows, you have to go beyond that initial calculation, find out where your second internal rate of return is, and look at that range. And you can do that by calculating net present value at various discount rates and graphing it. So that's what they're talking about back here. Whoops. When you solve for internal rate of return, you are solving for the root of an equation. And when you cross the x-axis more than once, there will be more than one return that solves the equation. Okay, so in this case, you would accept this project because between 10.11 and 42.66% internal rates of return, you have positive net present value. And as we said, if you just use your financial calculator and went, I can't use it. No, you made a wrong decision. So this is to alert you. Normally, if you have all positive cash flows, you're cool. But if you start having these non-conventional cash flows, you got to dig deeper. You can't just take it for what your calculator said. Are there any questions on that? And that's what they illustrate in your book. So no, on page 289, what they did was they calculated net present value using various discount rates. And the key, so let me show you this. So you could see their line of thought here. This project on page 289, year 0, they had to expend $60. Year 1, they have positive 155. Year 2, they have negative 100. Okay, so if we just did the IRR here and cite C11 through C13, it would tell us that the internal rate of return is 25%. And that is correct. That's one of them. But we know when cash flow changes, there's going to be more than one. So now we should start searching. So I'm going to start with a discount of 0. Then in your book, they go 10%, 20%, 30%, 40%, you can go up to 50%. What are you calculating here? Your net present value for using each of those various rates to calculate it. So let's see how I do here. Let me grab I know I stink at this one. It'll tell me. I should go back to the PowerPoint and let it tell me what I'm doing wrong. First, I'm going to cite C17 as my cell. Then I'm going to cite C12 through C13. And that's wrong because I still need to cite C11. There we go. Hey, I did it. So the net present value calculation, you take your discount rate, which mine's in C17, your cash flows in the future, not your initial cash flow. So it's C12 and C13 only. Close your parenthesis. And then on the outside of the parenthesis, put your year 0 initial cash outflow, C11. Now, if I do that, and I'm going to, watch this, I'm going to make C12 through C13 constant by putting $signs around the C, before and after the C. And I'm going to do the same with C11. So that's alerting the formula. When I copy and paste this formula in Excel, don't change those. Want them always referenced. Now to copy and paste a formula, you go to the bottom of the cell where your original formula is, wait for that heavy plus. That's wrong. C18. did something wrong on me. What's it doing? C12 through C13. Do I have to make these point? Yep. So you need to put these in as decimals so you know your interest rates, or else it won't calculate properly in Excel. Calculators are a little different. But what essentially it did was when I copy and pasted that original formula, the only thing that changes is the interest rate referenced cell. So it went to C18 and it said, okay, now I'm going to calculate the net present value of those cash flows. They didn't change. Those cells remain constant, but now with an interest rate of 10% and then 20% and then 30. So Excel could bing, bang, boom, calculate this for you very quickly. So that's how they got the results on page 289. Now you can calculate each one separately. Now, what are you focused on here? Right in here. Because your net present value, and that's what we calculated there, net present value. The net present value will go from negative to positive and then positive to negative. So that means it crosses the x-axis, goes up, and then comes back down and goes back over the x-axis. And you could see this picture on page 290. So page 290's graph is a graph of those items. So you can see when our interest rate being used to calculate net present value is 0, our y-axis, our vertical axis there, which represents net present value, is at -5. When it's at 10%, it's at -1.74. So there's no dot there, but that's what it's representing. When it's at 25%, which we don't have here, but we could find that because we know net present value goes from negative to positive over this range. Now, our first calculation gave us that 25%. So we pretty much know, okay, that's the point it goes up. Now we have to find the point it comes back down. And that's somewhere between 30 and 40%. So you can test those different interest rates between there to find that other internal rate of return. You could see where it crosses on the x-axis, so you can say, well, it's not more towards 40, it's more towards 30. It looks like it's about a third of the way if you properly scale your graph. So you can pretty much guess that first, second, or third try. But so this internal rate of return is between 25% and 33.33%. If your required rate of return is over that range, you're taking it because you have positive net present value over that range. Questions? We cool with that? Awesome. Okay, I'm going to go back to the PowerPoint and we're going to talk about the next issue, which is mutually exclusive projects. So you can only choose one. So there it is. You can choose Harvard or Stanford, but not both. Now, based on what we've known already, the tendency with this type of decision will be choose the project. So choose the choice that gives you the higher net present value, or choose the project with the higher internal rate of return. Because under both scenarios, you're making more money. Your return on investment is higher. Or is it? So we really have to look at this and make sure, are we choosing the correct project? Let's take a look. So let's say we have these two projects. Project A, mutually exclusive. We can only pick one. Project A requires cash outflow of $500, and then its inflows will be $325 and $325. So we can calculate, given that information, the internal rate of return. Remember, that's where net present value would be 0. So I'm going to go into my finance calculator, internal rate of return, and I'll put the cash flows, -500, comma, bracket, 325, comma, 325, close my bracket, and close my comma, or my parenthesis. Get 19.43%. I could do the same thing, putting the information in for project B. That's telling me a 22.17%. Let's calculate the net present value. Now, for project A, I'll go in to my net present value calculation, put in -500, or no, I'm sorry. I'm requiring a 10% return. So I'm going to put 10%, then -500. Then I'll start my bracket to put my two positive cash flows. Oh, hold on. Got my comma. Hate that. So net present value is 10, comma, -500, comma, bracket, 325, comma, 325, close the bracket, close the parenthesis, and I get 64.05. Whoops. Okay. Whoops, sorry. I'm clicking around here. Okay. So you can calculate both. Now, according to the internal rate of return, it says select the project that has the higher internal rate of return, which would be project B. But according to net present value, it says select the project that has the higher net present value, which would be project A. So you can see how these conflict when you have a mutually exclusive project. So let's see why, or what we do here. Well, what we should do is calculate net present value at various rates again for both projects. Okay. And this is also on page 292. Now, the red line here is the net present value at various rates for project A. So kind of what we did with the weird cash flows, the non-conventional cash flows, okay? But we're going to do that for project A only, various rates, and plot it on a graph. We just have to do it. A little bit more work. Do the same thing with project B, which is right there, the blue line. Now, at one point, some point, they will cross over. We call that the crossover point, which is 11.8%. And we could calculate that. That's the point that their net present values are equal. Okay, so how do you make your decision? Well, if your required rate of return, okay, is between 0 and 15% or 11.8%, you're going to probably select project A because the net present value is higher from 0 to 11.8%. If your required rate of return is more than 11.8, you will select project B because its net present value is greater than project A's after the crossover point. So that's how you read this. You have to plot the net present values by the discount rate for each project, find the crossover, and then based on what you want. So if you want a required rate of return of 15%, you should probably select project B because you're going to make more money selecting project B than project A at that interest rate. The net present value is higher. So this is what I'm talking about or mean when I say you've got to dig into these a little deeper when you have mutually exclusive project. So you're really selecting that project that's going to give you the most value, because sometimes based on calculations, they may conflict. Your internal rate of return answer may be different than net present value. That's not normally what happens, but in this case it did. So really take a look and find out, where am I making the most money? And you could do that by plotting your different net present values for each project under each interest rate. Any questions on that? Excellent. So our net present value directly measures the increase in value to the firm. So whenever there's a conflict between net present value and another decision rule, you should always use net present value. So our internal rate of return is a great tool, but it is unreliable when it comes to these two unique types of situations. So, whoops. There we go. Thanks, Bree. So when it comes to decisions where you have these non-conventional cash flows, mutually exclusive projects, you need to do these extra steps. Okay. So there are workarounds. One answer, so that you're not plotting graphs all day long, and you want to calculate an internal rate of return, is something called modified internal rate of return, which is great for those non-conventional cash flows. So there's different ways to complete this calculation. I'm going to take a page 295 so you can see the 3 different ways to calculate modified internal rate of return. You do what you like best, because under each of the 3 scenarios, you get very similar answers. The first is what we call the discounting approach, and that's what they have up here. Okay. I'm going to get out of here and go back to Excel, and we could take a look at these individually. I think we're still using, yep, we're using a very similar example like we were over here. We're using this example here. So now it says, remember when we looked at this, we said, oh, the internal rate of return is 25% and 33.33%. Okay, so, you know, if your rate of return, required rate of return is between that, then you should take it because the net present value will be positive. Well, the modified internal rate of return will get us a more specific answer. So one way of calculating a modified internal rate of return is to take, this is our first method, take any negative cash flows and discount them back to time 0. And you would discount them using your required rate of return. So you're going to find the present value of negative cash flows using your required rate of return. That's your first step. So you can see on page 295, that's what they're doing there. And they're saying, okay, my present value of that negative cash flow at the end of year 2, and you could even do this calculation in here. Present value, remember, our required rate of return is 20. The number of periods is 2, because this is at the end of the 2nd year, this negative cash flow occurs. There's no payment, and the cash flow is negative 100. I'm going to close that, and hopefully I don't get an error, and there you go. So the present value of that future cash flow of the negative 100 is 69.44. Now it's still going to remain negative because it's a negative cash flow. We also have at time 0 a negative cash flow of 60. So that's our time 0 or year 0 amount. So we add those two together and we say, okay, it's almost like saying the initial investment is negative 129.44. At the end of time 1, we'll have $155 positive. At the end of year 2, 0. So we're just modifying our cash flows a little to calculate internal rate of return. So we're still calculating the IRR, but we're modifying the cash flows to get a more precise calculation. So I'm going to go into my finance calculator. Whoops, that's wrong. Glasses on. And I'm going to go into my internal rate of return calculation. And instead of putting in negative 60 as my initial investment, I'm going to put in negative 129.44. Comma, and then in brackets, I'm going to put my first positive cash flow of 155. And then I'm just going to put a comma and 0 for my second cash flow. Close my bracket, close my parenthesis, and enter. And it automatically tells me your internal rate of return is 19.74%. And that is between, no, it's not. Okay. That will, that's, so that it's because of the 20%. It's not going to be between the 25 and 33.33. That's telling us that our internal rate of return, giving a 20% rate, required rate of return, will be 19.74%, or close to that 20% required rate of return. Another approach you can take. So that's one way of calculating your internal rate of return, but modifying it. Instead of bringing your negative cash flows back to present value, take all your cash flows except for your initial one and move them into the future at the end of the project. So we'll leave, so this is number 2. So we're going to future value all cash flows except times 0. So leave your initial one at negative 60. But now we'll find the future value of, so we're going to use a 20% discount rate again. At the end of year 2, oops, no, in one period it should be, we want to find the future value of 155. So we're only using one period because times 0 would be the end of year 1. What will be the value of that 155 at the end of year 2? So you can put this in your calculator as well. And it'll be $186. And that should be positive because it is a positive cash flow to begin with. So I'm just going to put it in as negative. So at the end of year 2, the value will be 186 plus, or I'm sorry, minus the 100. So now find the difference. Overall, it will be a positive $86. So we're just trying to make our cash flows either all present value or all future value. The first scenario, we made the negative cash flow present value. so that we can calculate a proper internal rate of return or modify it a little. In this scenario, you're calculating the same thing, you're just taking a different approach. Take all your cash flows except for that initial one and make them into future value. What are they worth at the end of the project? And then you can substitute that information into your internal rate of return formula. So your initial cash outflow will be -60, comma, and then I'm going to open up a bracket. At the end of year one, your cash flows are 0 because you future valued it, comma, at the end of year two, your cash flow will be +86. And then you close the bracket, close the parenthesis, and you get 19.72. So you can see the results are very similar. The last approach is on page 296, and it says, now this is a combo. And what it does is it discounts the negative cash flows back to present value, and it takes the positive cash flows and takes them into the future. So we're going to do that and that, basically. So we already know the negative, so number 3, we're going to present value all negative cash flows to times 0, and all positive cash flows are future valued to the end of the project. So the negative cash flows would cause our time 0 to be at 129, negative 129.44, because we took the negative 100 from the end of time 2, brought it back to present value. The present value of that is 69.44. So that means at time 0, our total negative cash flow would be 129.44. At the end of year 2, our total positive cash flow will be 186. The future value of the year 1's positive cash flow was 186. That negative 100 isn't at the end of time 2 anymore. We present valued it back. So now calculate your internal rate of return from that perspective. So you'll start with the negative 129.44, comma, bracket. At the end of year 1, your cash flow is 0. At the end of year 2, it's 186. Positive. Close your bracket, close your parenthesis, and your result is 19.87. So it's just 3 different approaches to get a rate of return on this project. And you can see no matter which approach you take, when you have those uneven cash flows, you get a very similar answer. So they're all acceptable there. Now, are there any questions there? Sorry, Ann. What am I doing? Going back to my PowerPoint. So that's what they're talking about there. There are some controversies about which one is better before we talk about profitability index, and you could read about that on page 296. The next tool you can use, and this tool is great if you are trying to rank projects, because maybe you have 5 projects that all have net present values that are positive, and you're like, oh, which one should we do? We only have this much money, okay? You can use the profitability index to really help you make those determinations. So this measures the benefit per unit cost based on the time value of money. A profitability index of 1.1 implies that for every dollar you invest, you are creating an additional 10 cents in value, or you're making $1.10 from that dollar. So you increase your value by 10 cents. So how do we calculate it? If you go to the middle of page 297, they talk about it. Middle of the page. Well, that's the, I'm sorry, go to the bottom of page 296. Bottom of page 296 is where they set up the example. If a project costs $200, so I'm just going to flip out of here. I thought there was an example in the PowerPoint. Bear with me a second. I will get us over back into Excel so you can see this. So if a project's initial investment is $200 and the end of year future cash flows are present valued back. So you've got to find the present value of future cash flows. They equal 220. Take the present value of the future cash flows divided by the initial investment. And that's how we get the profitability index. So again, the formula would be the present value of future cash flows divided by the initial investment. So we would have to, in any example, determine that first, because you've got to compare when you're calculating this, your initial investment to your cash flows in the same terms, present value. So bring them back, calculate that. So for every dollar of investment, you're making $1.10. So the increase in value is 10 cents. Are there any questions on that? Pretty straightforward there. And we're going to talk more about that, I believe, in chapter 10 with capital budgeting. So the higher this is for your projects that have net present value that's positive, then those are the projects you want to take on if you have limited resources, which everybody does. Okay, so if you have 6 projects you could take on that have great net present values, and you want to look at their profitability index to really rank which ones should be taken on first. Okay, so we have some positives and negatives here. We'll wrap this chapter up. So the advantages of it, it's closely related to net present value, generally leading to identical decisions. It's easy to understand and communicate, easy to do too. May be useful when available investment funds are limited, as I said, but the major disadvantage is it could lead to incorrect decisions in those mutually exclusive investments. Remember, you can only do one project or the other, so be careful of that. You want to make sure you're taking a look and selecting the projects that the net present values are the highest on. And we saw that in that crossover point on our graph. How is capital budgeting used in the real world? Well, net present value and internal rate of return are your most commonly used investment criteria. Payback is used secondary. So on page 298, they give you a great table of the percentage that companies use these various techniques. And you can see from 1959 through 1981, payback went from a really commonly used practice, almost never used, and net present value increased and internal rate of return increased significantly. as well as internal rate of return, because their information is more precise. And we saw that throughout the chapter. We talked about those advantages and disadvantages of each. Okay, and they also break it down by large firms versus small firms and how they capital budget. Pretty interesting. Okay, and how they use the different items. So there's a great summary of our decision-making criteria, net present value, internal rate of return, and profitability index. That's a great sheet to have, and that's in your book. More summary about payback and discounted payback period, average accounting. Okay, so what do we have here? 20 minutes. So take a few minutes and calculate these. Okay, I'm going to put myself on mute. I'll give you 10 minutes or so. So we're going to consider an investment that costs $100,000. So that's your initial investment. It has cash inflows of $25,000 every year for 5 years. So this is very straightforward, like the discussion we had the other day. There's no uneven cash flows. This isn't a mutually exclusive project. The required payback is 4 years. So calculate the payback period on this investment, the discounted payback period, the net present value, and the internal rate of return. And then, should we accept the project? And if we do, which one of these should we use to make that decision? Okay, so take a few minutes, try that, and I'll come back on in about 10 minutes and we'll review it and we'll be done. Any questions? Tuesday.